Thank you very much. It's wonderful to be here. I don't think I've ever been introduced in as nice a way, and as funny a way, and as embarrassing a way. Writing papers fast is easy if you know what you want to say, and I knew what I wanted to say because that workshop had been so good, and we'd figured out exactly the points we wanted to make. I'm used to sort of running around when I give talks, and I can't because I'm having to look at that camera there. So excuse me if I get sort of spastic with my arms. But I want to start with this slide. Yesterday, I was starting to prepare my talk, and I was, of all things, I was bicycling back from the bank where I had a meeting with my banker to discuss my mortgage and my stock portfolio and everything. And in the course of thinking about stock portfolios and so on, this cartoon, which had been in the New Yorker about a month or two ago, popped into my head as maybe one of the good introductory things. And in a sense, it captures for me a lot of the place we need to start with when we think about climate change, or at least when I think about climate change, in that it would really be an awful shame if we destroyed the planet just to improve our stock portfolios. At the same time, our stock portfolios are things that matter to us and guide our decision making a lot. And in a sense, that's what this presentation is about, is trying to think outside the box in terms of if we think that our stock portfolios shouldn't really determine the fate of the planet, yet at the same time they do determine a lot of our day-to-day decisions. So hopefully some of the thinking here will be outside of the box. I'm going to start with some very inside the box thinking, which are some things that come out of the latest IPCC report. The upper left-hand graph there comes from a paper describing the so-called representative concentration pathways, RCPs, and it basically shows what we would need to do if we're going to stop really bad climate change. We would need to limit global temperature change to 2 degrees centigrade, and that would mean following this lower trajectory of emissions, which in IPCC speak is RCP 2.6, which stands for 2.6 watts per meter squared of forcing, which is an awful lot less than the baseline emissions on there. So those are baseline, and then RCP is down here. And what we see about the RCP 2.6 trajectory, at least the median line, is that it's down below about 0 sometime in the second half of the century, which means really it needs to be headed definitely towards 0 in the next few years. Let's say by 2030, 2040, we ought to be pretty confident that it's headed down towards 0, which is something that a lot of people think is impossible. And I'll leave it to you to judge whether or not you think it's possible or not. They think it's impossible just because we haven't really been going there so far, and we don't seem to make any signs of changing. The overall costs of achieving that, if you actually look at the numbers that are published in the most recent IPCC report, are pretty minor. So the baseline, this graph on the lower right-hand side shows the baseline, the median of the baseline scenarios in red, and what it shows is the median of what those scenarios show the global economy doing over the next 100 years. And that those, between the scenarios, they show a range of about the economy becoming 3 times bigger to about 12 times bigger over the next 100 years. And so that's the median. And you might ask yourself, well, when will the economy be 5 times what it is today, the global economy? And 5 times is in about 2080. And then you could ask yourself, how much later would that occur if we were to reduce emissions to the level of this RCP 2.6, which is what we need to do if we're not going to destroy the planet? And the answer is, instead of hitting that 5 times the size of the current global economy in 2080, we're going to have to wait another few months, which is, I would say, pretty trivial. That the decarbonization scenarios, they represent about a 1 to 3% reduction in economic growth on the baseline. Whatever baseline you choose with a set of assumptions, if you add a carbon constraint in there, it reduces your growth by somewhere between about 1% to 3%. And if you translate that into the big picture, it means we would have to wait a little bit longer. Questions? Oh, am I allowed to take questions? Sure, I'll take a question.
Would you like to have questions now?
No, but no, just no. That's fine. Why don't we take questions at the end? Then I won't lose my flow. If I start taking questions, it'll throw everything off. Anyway, so let's agree that if we're going to stop if we're not going to destroy the planet, we need to be thinking about really getting our emissions down, the total cost of doing that, and that most of that is coming from the energy system, but a fair amount of it from the land use, from land use. Something like 56.6 of greenhouse gas forcing comes from CO2 from burning fossil fuels. This is sort of also CO2, which from other industry. Methane is mainly coming from a lot of it from the energy system and some from agriculture, all those cows doing what they do, and a fair amount from other stuff. So we can't solve climate change unless we solve the energy system, and that's mainly what I'd like to talk to you about because I don't know too much about land use. And if we think about the energy system, it's not that complicated. First of all, we have something like 20 to 40 years to get our emissions really down if we're going to not kill the planet, although if we take longer, we take longer. But the closer we can start to make real difference within 20 to 40 years, that's really good. If we talk about what that energy is going for, it's going for transportation, it's going for heating, and it's going for all our little gadgets. And if we're going to decarbonize it, well then with transportation, we're thinking about switching transportation from fossil fuels to electricity, to biofuels, or to hydrogen, but hydrogen comes from something and ultimately from the same places that electricity comes from. If we're talking about heating, we're talking about electricity or biofuels, or electricity in combination with a heat pump, which is geothermal, but it's still electricity as the energy going into that. And if we're thinking about gadgets, well, that's electricity. And so at the end of the day, we're thinking about how do we create biofuels and how do we create electricity in ways that are sustainable and carbon neutral. And so I would say let's think about, before I go further in this talk, 4 points roughly to agree on. We've got a problem of establishing a CO2 trajectory towards zero within 20 to 30 years, where the effects on the economy as a whole are of relatively minor concern. Of course, to certain pieces of the economy, we should be worried very much, especially if there are those poorest people. But that's different than saying the economy as a whole. I think if we're going to be growing by a factor of 5 over the next few decades, it matters a lot where that growth is going to take place. But the total amount, changing that by 1 or 2 percentage points is pretty trivial. For which we need to grow a lot of plants for biofuels sustainably and or produce and store a lot of electricity that doesn't generate carbon emissions. So the question is, how are we doing on that so far, and are we going on the right track? I'm going to backtrack a little bit. I first started worrying about this whole problem on a snowy day in January 1993. I'd gone skiing in the morning. I lived in Vermont, and I was an environmental lawyer. And I'd gone skiing with some friends in the morning on that day, and then I went home, and on my way home, I thought, what's my perfect afternoon? And actually, my perfect afternoon is reading a book in front of the fire after having gone skiing with friends in the morning, and that's still what I still try to do, which is why I'm in Switzerland now, which is a good place for doing that. But on that particular day, I stopped at my favorite bookstore, which was this one, Deer Elite Books. There's the deer up on the weather vane, and I bought this particular book, and I read it. And what I realized was that after having read this book, which I did in one afternoon, was that this favorite thing of mine, reading a book in front of the fire after having gone skiing in the morning, was not going to be available to my grandchildren unless something changed in the world. And that's when I started thinking about how do I, instead of worrying about little local environmental problems, which is what I was worrying about at the time, things like toxic waste, how can I worry about this big issue? Because toxic waste doesn't get in the way of skiing, but climate change does. Anyway, that was about 20 years ago, a little over 20 years ago, and that you would think that would have been a great time to start worrying about this, because actually 2 big things had happened right around 1993. First of all, it was just after we had signed at the Rio conference in 1992. Countries of the world had signed up to the biggest treaty ever, essentially, in the environment, the United Nations Framework Convention on Climate Change, and we thought that ought to work because the treaty, which had just been signed not too long before, was the Vienna Convention on ozone-depleting substances, and had led quite quickly into what has proven to be a pretty good solution to that problem. And everyone was pretty hopeful that this milestone, having just been passed, would actually work. The other thing that had happened right around then, and it's hard to read this bottom graph, but that shows sulfur dioxide emissions in the United States in, well, this is 1990 and this is 1995, because actually in 1995 is, well, just before 1990 is when the United States Environmental Protection had done a really landmark thing, which was to design an allowance trading system for sulfur dioxide, with the first limits and the first trading market coming into existence in 1995. And everyone was wildly optimistic that that would achieve a level of emissions reduction in a way which was attractive to industry and low cost. And in fact, with sulfur dioxide emissions, that's pretty much worked. And so these two things, on the one hand, one was a real progress in governance at a global level, and the second was real progress in the design of a regulatory instrument at a national level, ought to have made one be really optimistic. And in fact, you could say, well, it was these two things. The first one, and this is what the UNFCCC is about, is really, it's structured about fixing a tragedy of the commons. It's structured around getting, and that's how the Kyoto Protocol was structured, getting countries to agree to a limit within a global limit, which would then be enforceable. And it's taking the same model of too many sheep grazing on the meadow. It's too many countries putting too much CO2 into the air, and we'd all be better off if we all limited it. And the second one is, let's get polluters to pay for their pollution, and then they'll have an incentive to reduce it. Unfortunately, it just hasn't worked. And the latest report that's come out of the IPCC, well, if this was 1993, that day skiing right here, emissions have simply risen, and they've accelerated. And they've accelerated in the last decade over the previous decades, having been growing at about 1.3% a year in the last decade, or at least between 2000 and 2010, growing at 2.2% a year. Most of that growth has not been in countries like this. Most of that growth has been actually in Asia. This is a complicated graph. More complicated than it needs to be for my point, but I'll just describe it anyway. The solid line shows the emissions that actually happen within, say, OECD countries. The top line shows, or the range tells you how much CO2 emissions are accounted for in the things that we import or export. And so the dotted line is consumption-based emissions. And so the OECD countries, which is us and the rest of Europe and North America and Australia and so on, we import a lot of CO2 emissions. But even if you take our CO2 emissions that we've imported, we're fairly flat. Asia, their dotted line is below, so they're exporting a lot of emissions. But either way you cut it, their emissions are just rising astronomically. And that is mainly what's behind it. And mainly what's behind this is the astronomic rates of economic growth that they've been having in Asian economies. And that's what's been driving the rise in emissions. And arguably, the desire to have that economic growth continue in countries like China, which are still an awful lot poorer than we are, is what is continuing to drive the challenge of negotiating a global treaty that has meaningful emissions reductions for all the different countries. So now here is where I want to then start to opt for the difference between theory and practice. In the Zurich Airport this morning, I saw this sign, so I couldn't not take a picture of it. You know, I think the theory is that if you're this watch company, it would be great to have Ronaldo be the guy who's not cracking under pressure. But practice a few days ago tells us that that actually is not the case at all. If we think about some other personal stories, if you move from the United States to Europe, or North America to Europe, one of the big things you notice is that the whole way that road signs are constructed are on a different model here. And I'm going to and sometimes simple. The European road systems, you all know it. You drive into a country and you see this sign, and it shows you what the speed limit is in these different kinds of zones. And so some planner in Europe has a zone, has a picture on a map of the different zones that roads go through. So you might have countryside, and then inside there you have an industrial zone, and then within that you have a school zone. And so the European signage system is going to tell you're driving through Croatia nicely at 80 kilometers per hour, and it's going to tell you you're entering the industrial zone and the speed's going down to 60, and then you enter the school zone and it goes down to 30, and then it tells you you're leaving the school zone. So it's got back up to 60, and then you're leaving the industrial zone and it's back up to 80. And it all makes perfect sense, except when you have to deal with it in real time. And the question to ask on top of the simple model based on zones is, how much does task performance suffer when people are actually trying to remember sets of numbers in their heads? And there's actually psychological studies showing that task performance falls off significantly when you're having to keep numbers in your heads, which is why I think, let's call it the Canadian signage system, because unlike the United States, they're at least on the metric system, so we have the same kinds of speeds. But they have a sign system which doesn't tell you where you are in these zones, it just tells you how fast you need to go. And you don't have to remember the zones that you've been traveling through. So it's a slightly more complicated model. The European sign systems works great based on a really simple model that works on a piece of paper, but when you translate it into the real world, there's evidence to suggest that it actually underperforms this other system, which works better if you think about a little bit of psychology. Anyway, so one of the people I think who's thought about this a fair amount is David Victor, who's a political scientist in California, who wrote what I think is an excellent book a couple years ago called Global Warming Gridlock, and started to think about moving beyond the simple theory of international relations and how these treaties worked. And the simple theory is this tragedy of the commons theory, that there are too many sheep on the commons, and so we need to put a limit on the total number of sheep, and each farmer gets some piece of that total number. And what I think David Victor and some other international relations people, a couple of whom are sitting in this room, have shown us is that doesn't necessarily match what happens in the real world for various reasons. And I think what I got out of his book is that we can think about a simple model of treaty formation, and we can think about a not so simple model, just like the European sign system is a simple model, or Ronaldo is a simple model, and we can then think about the not so simple model and think about the difference. The simple model is that if you look at states' intentions and then signing a treaty and then the desired outcome of signing that treaty, the simple model is that states have an intention to act conditional on other states acting. So I will reduce my number of sheep if I know that all the other farmers are reducing their number of sheep, and then we'll all be better off. So I sign the treaty as a way of making sure that all states do that thing on which my intention is conditional, namely that all states reduce it. And so we have a treaty there, and I'm only willing to reduce mine if that treaty is in place, because that's the only way I benefit economically. And part of the treaty there is that we need to police free riders. So if one farmer has too many sheep, all farmers need to brand their sheep so we know whose they are. And if there are too many sheep from Farmer Jones, we need to tell Farmer Jones, get that sheep off the field. And we need to do so the exact same thing for climate change with emissions. So we need to carefully monitor emissions, and we need an enforcement regime and everything else. What Victor and others have observed is that actually treaty formation works differently. That it actually it seems to start, with an unconditional intention to act. So state X actually decides, I want to do this. And I actually wish other states would do this as well. I know I do, but how can I get my neighbors to do the same thing, which is better for all of us? And I signed the treaty as a political move to put the pressure on other states to then sign the treaty and to do the same thing that I'm doing. And I think one of the best places to see that isn't with climate change, because it's maybe not so intuitive there, but it's real intuitive when you start thinking about human rights, for example. Every state, or a lot of countries want to have certain human rights standard in place. And that isn't really conditional on what other countries want. They want human rights of some set because they think it's valuable. But they go into signing treaties on human rights in order to create this momentum globally for all countries to buy into a set of human rights standards which match their own. And I think the empirics of treaty formation is really that. It's a, and so you could say from this, countries only agree to those treaty commitments that they would also undertake in the absence of a treaty. And the ideal treaty will get them to agree to everything that they'd be willing to do on their own. So if country X is willing to reduce its CO2 emissions by 30%, no matter what the rest of the world does, a well-structured treaty, in a well-structured treaty architecture, that state will actually commit to 30%. In a poorly structured treaty architecture, that state might only commit to 20% or 10%, which is what Victor argues we actually have. He actually argues that the architecture of the Kyoto Protocol and the UNFCCC is poor, and states are actually committing to do less in the treaty than they would actually be willing to do on their own. So the European Union, for example, signals that it's willing to cut emissions by 30%, but in the course of the treaty is only willing to commit to 20%. The reality of the situation is that most OECD countries have demonstrated an intention to reduce emissions roughly consistent with the RCP 2.6. Domestically, certainly by no means in the treaty as a whole, but the European Union is doing the stuff it needs to do to bring down its emissions by something like 80%, by something like 2050. They're putting in place the planning processes. The stuff is going on, and there are analyses of this that show this. Not all. I think Canada's not doing particularly well, even if they're on the metric system. The United States is taking steps. Okay, maybe it's not as good as Europe. Some parts in the United States, the state of California, is taking remarkable steps, roughly equivalent to the European Union, in terms of getting the planning processes, figuring out how they're going to reduce their emissions. Roughly, we did a report I'm going to show later a little bit. We analyzed within the European Union is if you take a particular view towards how countries in the European Union would reduce their emissions in reality down to RCP 2.6 kinds of levels, do we see evidence that the European Union countries are actually doing those steps now that are consistent with reaching that by 2050? And pretty much we found the evidence was yes, they are. And so the question to my mind is not how do we get all countries into a meaningful treaty right now, because I don't believe we will. The question is how do we make good on our intentions in OECD countries in such a way that we create the conditions whereby the rest of the world is going to want to copy what we do. And I think that there are a couple, one way of doing it, a good way, is if we reduce our emissions, we get them to copy us by showing that mitigation doesn't hurt the economy very much. And that's, I would say, a short-term view. A better way would be by making mitigation something that doesn't hurt the economy at all, if that's possible. The short-term view, I think this requires a lot of innovation, and innovation takes time. About the time that the UNFCCC was agreed to, I think no one imagined that it would be 30 years before that 30 years later, 20 years later, we still wouldn't have a meaningful protocol. We'd had such strong success with the Montreal Protocol on ozone reduction following the Vienna Convention, that I think most people thought within 5 to 10 years there would be a meaningful protocol where countries would agree to meaningful emissions reductions. And so I think they saw it as a two-stage process. We signed what became the Kyoto Protocol, where the OECD countries roughly commit to doing something, and then the next stage, a few years later, would be the developing countries sign up for that as well. And so I think people weren't thinking in time perspectives over which we could actually change mitigation into something that doesn't hurt the economy at all. They were thinking much more about this shorter term thing. And I think in line with that shorter term thing, they were thinking very much along the lines of a standard sort of static economic model. And maybe most of you have seen this. I hope most of you have seen this. The graph on the left is really the simple model of supply and demand within economics, where you have a marginal cost curve, which is your supply curve, which is rising, and a marginal benefit curve, which is your demand curve, which is falling. And they cross somewhere at this blue point, and that's where the market ends up. The market ends up with a quantity, an equilibrium quantity being consumed at an equilibrium price. And that price is, that market position happens to be the thing which maximizes the sum of consumer surplus, which is the benefit we all get out of consumption, with firm surplus, which is firm profits. This is the best place you want to be, and that's what the market does. And as economists have shown, if you throw in pollution, it creates a problem. You get marginal social costs, which are higher because of this cost of the externality of the pollution. And this standard economic model shows that this blue place is not the place you want to be. In fact, you want to be at this red place. That's the social optimum. And how do you get to that red place? Well, you get to that red place one of two ways. First of all, you can limit the quantity produced, move it over to the left there with something like a pollution cap, or you can put a price on the pollution equal to the cost of its marginal cost to society in the form of a carbon tax or something. And the economic models show quite nicely, I think. First of all, one, setting a carbon tax at the marginal damage cost will reduce pollution to the efficient amount. It'll get you to that red point. Second, setting a tradable cap at the efficient amount will result in a carbon price equal to the marginal damage cost. So essentially, the cap and trade system and the tax system are pretty much equivalent. There are differences, and economists have shown us how. Either instrument, this is point number 3, either instrument will be initially less costly to society than other instruments like technology standards. And fourth, both instruments will provide firms with some incentive to innovate, bringing down costs even more in the future. But I think really the focus was on this point number 3, and it was going back to this idea of how do what we really want to do is in the OECD countries put in place policy instruments which can show that mitigation harms the economy as little as possible. So we want the mitigation to be as least costly as possible in the here and now, and so we want these kinds of instruments. Of course, there's one thing that the model could have in it but doesn't, and that is to think what would happen if instead of putting in place a tax here to make the cost to consumers equal to the marginal social cost, what if you could figure out a way to get the marginal benefit curve to move to the left, the demand curve? And indeed, if it were to do so, you could get to this green point, which would be also at the socially optimal level of pollution. And indeed, if the demand curve were to continue to go to the left, you would see falling levels of pollution even below the socially optimum. That can happen. One of the ways that can happen is if you find other goods which are substitutes for this one that causes the pollution, that you actually want for reasons other than just for pure economic reasons. And that's if and that happens in the case of climate change if you've got a lot of co-benefits associated with these other goods. So if you find these other goods which are substitutes, let's say for fossil fuels, which you want to use for other reasons, that could actually reduce your demand for fossil fuels. And in fact, research has started to show this. At my former institute, they've done a lot of research on this. At YASA is my former institute, looking at, for example, the co-benefits in terms of local air pollution of greenhouse gas mitigation. This graph shows the relationship between cuts in greenhouse gas emissions on this x-axis and cuts in air pollutants that we care about, sulfur dioxide, nitrous oxides, and fine particulate matter. And you see, depending on the particular pollutant you're caring about, but in all cases, significant drops in local air pollution when you go for many of the common mitigation methods, like switching from coal-fired power plants to natural gas or something. And these turn out to be non-trivial. And if you start to come up with cost curves, this is in that same paper. It's looking at marginal abatement costs in Europe per ton of CO2. For example, in the power sector, power plants, we see a fair amount of abatement that can occur at less than zero marginal cost, if you include these co-benefits associated with air pollution reduction. In other areas like buildings, we see abatement that's at below zero marginal cost even more. And the more that the closer that the costs of fossil fuel alternatives get to fossil fuels, the more we should see marginal abatement costs being below zero or up to higher levels. And indeed, in the most recent IPCC report, we look not just at this, but we look at a whole host of possible co-benefits that people have identified. Many of these have been identified but not really researched very well, at least quantitatively, but other things that you might get out of reducing emissions. And so one of them is, well, air pollution is somewhere here. Air pollution here. So that's the one that quantitative study I just showed up was. But there's been a fair amount looking at a whole lot of other things. And these are both co-benefits, but in some cases co-harms. So things we worry about, like land use competition, maybe increases when you're relying on more biofuels. But other things, energy security often, and we've done work showing this, benefits from greater attention to renewables. Anyway, but the basic economic model doesn't look at those co-benefits because to a certain extent it's outside the model because you assume it away, because if the co-benefits are there, then people are already taking advantage of them and we don't need policy to put it in place. So it's not there in the model, but if we take the model, it's then worth asking really how important are each of these benefits? And this third one you can kind of show with with math, that they will be less costly. This fourth one is sort of a bonus effect. It's a bonus that everybody in a market has an incentive to innovate. We don't really know if or there's nothing in the economic theory of these market instruments to show that the incentive to innovate will be greater because of these instruments than others, and I'm going to get into them in the future. But let's start with number 3. Either instrument will be initially less costly to society than the less flexible instrument, like uniform standards. And this is a picture, I guess you can't see it too well. It's an apple tree, and here's a ladder. And the point of the matter is that it's well demonstrated that when you have low-hanging fruit, the economic instruments are really good at getting people to pick them. So if they're easy emissions reductions, cheap emissions reductions, the CO2 price is a great way for when firms respond to that by finding those low-hanging fruit and picking them. So in Europe, for example, one of the main effects of the putting in place a cap-and-trade system has been getting firms to improve the efficiency of their coal-fired power plants, for example. The problem is, and again, the economic argument doesn't really tell you what happens if you have to pick the whole apple tree clean. If you have to pick all the fruit off the apple tree, there's not necessarily as much of a benefit from the economic instrument, because the thing is, if you've got heterogeneity in costs across different firms, across different countries, the economic instrument allows you to do the emissions reductions where the costs are the cheapest. But if ultimately you need to eliminate all emissions, you've got to do it in the places where it's as expensive as well. And so the benefits of having that flexibility just aren't there. And we had a paper where it was more of an editorial kind of thing, where we argued really that the thing we need to be focusing on in this picture isn't the low-hanging fruit, but it's the ladder. Eventually we're going to need the ladder to get the fruit at the top of the tree. And we need the instruments which get us to build that ladder, which then gets to this second line, which is the incentive to innovate. if we think about the innovation isn't just a black box. There's stuff that happens in innovation. It happens in different places. It often starts with basic research in the scientific or engineering lab. It goes on to moving that research into commercial viability, often in firms, most usually in startup companies. And then eventually it goes through a process of market diffusion where these innovations that work out there in the real world but aren't necessarily competitive gradually scale up and become more and more diffuse, or sometimes they don't because they don't survive. But the ones that do survive diffuse through the market to the point where they become mainstream. And if we look at who finances that, it's particular actors usually. Basic research, of course, is very risky, and it's impossible to tell when it's going to pay off. And generally, we don't expect the private sector to engage or to fund basic research. It comes from government funding. It happens in universities, it happens in research labs, and we get government funding to pay for that activity because the government is there to, it's an organization that can take this risk because in the long term it believes it's good for society to do so. What funds this process? Well, in the startup firms anyway, when commercial viability, moving something to commercial viability happens in large firms, it happens with cash on hand that the firms have. When it happens in startups, it's usually funded by venture capital. And what about market diffusion? Well, market diffusion happens by firms, by people building solar PV panels on their roofs, or by firms doing something, investing in something new. And the money for them comes out of debt and equity finance, which is how money comes for most stuff in the world. There have been a lot of papers over the last decade looking at what drives these things to happen. And looking in particular at the people involved in venture capital, looking at the people in debt and equity finance, under what conditions are you more likely to put the money into this process? And so there have been, looking at this stage, there have been opinion and conjoint analysis, that's a particular kind of survey instrument, of venture capital investors, comparing and asking them questions. Under what policy conditions are you more likely to put your money into place? There have been comparisons of venture capital flows and looking which countries those flow to and correlating that with the national policy instruments in place. In the case of market diffusion, again, there have been opinion and conjoint analysis surveys of investors and lenders to try to see what kinds of instruments they actually are more likely to respond positively to, and also comparison of diffusion rates. And pretty much all of those studies show two things. First of all, they show it's incredibly important to have clear, simple policies in place that people can understand. And second of all, it's incredibly important to reduce the risks to these people, because these people operate already under conditions of very high risk, that in general, if you can get their rate of return above some threshold, then they're happy. And if it goes further above that threshold, they're still happy, but not much happier. But if you can reduce their risk, no matter how, the more you reduce their risk, the happier they get. And the risk element turns out to be more important than the rate of return once you cross that threshold. In terms of the simplicity, I think this is a fun picture. This compares the simplicity of the Swedish support scheme for wind power with the German support scheme for wind power over the period 1991 to 2014. If you were going to put money into a windmill in Sweden, you'd have to worry about the money coming from 4 or 5 different places. If you're and you'd have to, it's a lot of paperwork to fill out for one thing. There's a lot of uncertainty with many of these things, like the spot price, but it was a pretty complicated thing. It tops out at 8 cents a kilowatt hour, and this tops out a bit higher. With Germany, it tops out higher, but it's also at any given point in time, you had to worry usually about one source of money, and at most 2. And the clarity was just a huge amount more. And if you compare the scale up of wind in Germany and Sweden, it's a little bit different. The risk element really shows up as an important, and I want to turn to just bring up an article. I read this 2 days ago, and it's just so wonderful, I couldn't not bring it in. It was a paper on the biology of risk. And what they found, and it was people who've done studies looking at cortisol levels in the blood. So they get people in situations like stock traders, and they take blood samples of these people on the floor of Wall Street. And what they find is that periods of high market volatility lead to steadily rising cortisol levels in investors' blood. High cortisol levels lead, and then, so that was the thing on Wall Street, taking blood samples. Then in laboratory conditions, they took a control group who just had normal cortisol levels, and they compared them to an experimental group where they injected cortisol into these people's blood. They artificially raised their cortisol level, and they found that, that the group with the higher cortisol levels had they were willing to take less than half of the risks that the other group. There was just this biological trigger of risk-taking behavior, and it doesn't follow our sort of standard economic model. In other words, our love of risk changes in response to our environment, and it changes in ways we don't quite understand, and it changes cumulatively over time. Cortisol, it turns out, accumulates in our blood over the course of weeks. And so if you're in one highly risky, if you don't know whether your kid's going to get into college, you're less likely to invest in a PV plant or something. It's just crazy. What they found, they looked at this. They were looking at how changes in Federal Reserve Bank policy was affecting risk-taking behavior on Wall Street. They found that since about 1994, since the mid-1990s, the U.S. Federal Reserve Bank has made an active policy of trying to decrease the volatility of prime lending rates and also signaling well in advance what those changes will be. And what they found was that, and what's consistent with this stuff on the left, is that right about when they started doing that, and this was when Alan Greenspan came in as Fed chair, that risk-taking behavior skyrocketed. That there was this whole level, and what you could presume was when you had this kind of volatility in prime lending rates, this was creating such high amounts of uncertainty that people just were shying away from any risks that they didn't need to take. And that the propensity for risk-taking behavior has really increased, which unfortunately is exactly what the Fed wanted to avoid. But in the energy area, it's in fact a little bit the other way around, because in the energy area, if we want innovation, innovation is risk-taking. You cannot innovate without taking a risk. You're experimenting with the unknown. And in the energy area, we want to create conditions where people will take risk. We want to be this kind of thing. We want to be signaling far in advance how policies will change. Unfortunately, the policies that we're putting in place or say we should be putting in place don't do that. If we look at the ones that everyone says we need, which are cap and trade and carbon taxes, you can sort of map them out according to their effects, the uncertainties that are relevant to those effects, and then the things that are driving those uncertainties. So cap and trade works because it changes fuel costs and power prices. And these things are sensitive to the level of the cap, the price of the cap, the fuel costs, and the power price. The level, the price of the cap is not fixed. It varies according to the relationship between the size of the cap and how binding that is within the economy. So when you hit a recession, you have the same cap, but the cap price goes down, as has happened in Europe. If you look at the things which affect these uncertainties, it's all of these: political decisions, economic growth, fossil fuel prices, power market prices, technological change, supply of fossil fuel power, supply of low carbon power. All of these things contribute to the level of uncertainty that investors have to deal with under a cap and trade system. With carbon taxes, it's about the same. It's a little bit less because at least you know what the carbon price is going to be if you can predict politicians. You don't have to worry about a recession making a cap non-binding and then pushing down the cap price. The instruments that economically have been demonstrated to be less efficient, by contrast, do pretty well when it comes to uncertainty. In fact, there are a lot less uncertainties that affect investors' behavior with these instruments. Renewable quotas give you market access, and so there's a little bit of uncertainty about what the future level of the quota will be, whether the supply, what it will be, and what power prices will be. Investment subsidies affect your fixed costs, and so there's some uncertainty about what power prices will be in the future. And if you add those, if you add together the subsidy and the power price, you're still going to make money. And then you worry about the sunset if the subsidy is going to be canceled. Feed-in tariffs appear to be the most effective instrument at stimulating investment because they get rid of most uncertainty. You don't have to worry about any, if with a feed-in tariff, I don't know if the people from Texas know how it works, but with a feed-in tariff, if you put a photovoltaic panel on your roof in Germany, or at least if you did until last year, you had the right to sign a 20-year contract with the power company. The power company was obligated to purchase all the power you generated for the next 20 years at a fixed rate. There's no uncertainty there at all. Well, it might be cloudier, but that's pretty predictable, how cloudy it's going to be in Germany pretty much all the time. So you know how much money you're going to get. You don't really have to worry about anything. The only thing which screws up feed-in tariffs, or until very recently when everything screwed them up, is that you worried about whether the feed-in tariff was going to end soon, and that gave you an incentive to try to put up the PV panels now instead of waiting a year, which in some places where they were poorly designed, like in Spain, it really overheated the market and didn't work so well. What's been the result of these feed-in tariffs and the subsidies? Well, if we look at the PV market, I could get country data. I looked quickly. If I'd really looked hard, I could have found country data through last year. I got country data through 2011 and global data through 2013. Despite an economic recession, PV has just been growing exponentially, and it doesn't show any signs of stopping soon. In fact, it may be at the point, and people are saying it's at the point, where it doesn't even need feed-in tariffs anymore. We're in some places. Basically, Germany is accounting for about half of that. That's the light blue there. All of the countries where it's grown significantly have been because they've had a feed-in tariff or some sort of investment subsidy. Over this same period of time, costs have fallen dramatically. And of course, we all know that that correlation doesn't equal causation, except when it does, and in this case it does. That as quantities grow, it's almost a natural law that as quantities grow, prices fall. For every single technology you look at it, you can find some sort of an exponential curve here. So these show different points in time and how much global installed capacity there was in photovoltaics, and actually it shows two different technologies. This is silicone technology, and this is thin film technology on the bottom line. First Solar is a company that makes thin film, and they're cheaper, but they are less efficient, so they take more area. So you can't generate as much power on your roof, even though it's cheaper for every kilowatt hour you do. And they pretty much, they departed from this line here when there was a bit of a bubble in PV investment because of the Spanish thing, which created this incentive for everyone to build all at once. And that created a constraint in the market, and prices went up. But then once the Spain's economy tanked and that went away, then we got back down to this line. And that's where we are, and that's where we're headed. The feed-in tariffs have, in the last year or so, created a huge amount of problems in Germany. They've created a huge amount of problems from the fact that so much PV has been built. I don't really want to go into that. The way they're structured, they create a disincentive for a lot of other kinds of investment. I'm from Switzerland. The German feed-in tariffs are causing problems in Switzerland because when it's sunny in Germany, a lot of the way this feed-in tariff is structured, a lot of cheap power gets shipped down to Switzerland, and then the owners of the hydropower plants can't sell their power, and they're pissed off at the Germans. I think the relevant question is to ask, would the world be better off, would Germans be better off if the feed-in tariff had never taken place? I think that the answer is no. I think that the world is in a much better place because of the German feed-in tariff over that period of year. We've taken this technology, which was very expensive, and turned it into something which is getting to be competitive. I even think the Germans are probably in the long run going to be better off for having had this feed-in tariff in place. Right now, the feed-in tariff is costing German households about 300 euros a year in terms of increased energy bills, which is about 1% of their income, which is actually about what on my first graph it showed that mitigation ought to cost. So if Germans did the Feedin tariff and were to do nothing else, I think we're not in a bad place. I had a story I wanted to tell, but I'm going to skip it so I can finish this. I'm getting to the end. You know, at the end of the day, what we want for climate change is something like this picture. This is this shows the number of horses and the number of cars in the world over a period of 150 years, during which time the total number of transportation units has been growing roughly exponentially. And then there was this brief shining moment, not of increasing return, well, a brief shining moment for amazing profits in the automobile industry, where essentially horses all died and weren't born anymore, and cars started to be built really fast. And if you'd been looking at it, and the author of this paper, Arnulf Grubler, and his co-authors, Nakina Kacenovich and some others with even fancier names, you know, they fitted it to a mathematical curve, which you could say is a pretty good fit. And if you'd been looking at the problem, let's say in 1900, and the number of horses was growing and everything, and in 1900 you would have said, you know, this is kind of hopeless. And in fact, the biggest urban pollution problem of the day was horse manure and all the stuff that horse manure caused in cities. That was a really big problem. And how do you get rid of horse manure in cities? And nothing that people could do could seem to quell this growth in the number of horses. They didn't try a manure tax, but if they had, I'd bet it wouldn't have worked. If it had been in 1875, because there was simply no good substitute for horses at the time for transportation, and the overall growth in the industry was just driving this growth in the number of horses. Well, something happened here in a very short period of time to change everything. And one of the questions is what? And some researchers have started to look at that, and I think the best of them is a guy who started out in the Netherlands but is now in the UK, Frank Gales. And he looked at a number of transitions, including horses to cars, steamships, sailing ships to steamships, all sorts of ones. With the horses and the car story, what he discovered, I think is really interesting, is that it wasn't just a simple switch from horses to cars. There were some other things that came along which facilitated that change. One of them was the bicycle. There was a boom in bicycling in the late 1800s. The number of bicycles that people were riding around in the late 1800s was far more than it is today. And then it died out. The cars put bicycles out of business. Another thing that happened was the invention in cities of horse-drawn trolleys and then electric trolleys. Both of these led to a lot of changes in the way we organized our roads. And that bicycles were going faster than, actually when people were using horses, usually they were just sort of walking along. And you didn't really need rules. And then people started going a little faster on bicycles and going in ways you couldn't stop easily on these things. And the invention, for example, of the idea that traffic went on the right and on the right, that was like in 1890. The invention of things like stop signs, of signs, of roads that were paved or at least smooth and not just mud, that was because of bicycles. You had a whole lot of things which changed at an institutional level. Traffic laws, smooth roads. You had, with cars, the big driver of technological change was recreational car racing, which was it was an activity for the rich and famous, but it got us, and they would have these big rallies across the countryside, it got us networks of fuel and people who could repair these cars starting to exist. And all of this kind of created the trolleys changed our expectations. It made it possible to get around cities without owning your own horse. And then enough people started not owning their own horses that they realized how much easier their lives were when you didn't have to get up at 5 in the morning to feed your horse. And maybe that would be nice for everybody. So you got a whole lot of changes which then allowed, in a very short amount of time, this transition to occur. And And Gales has sort of put together a theory which he calls the multi-level theory. Others have put it together too, where you have to look at things happening at several different levels. So at the bottom level, you've got changes in the technology. You've got changes in price, performance, and reliability, which was happening with the cars, for example. At the top level, at the middle level, which is where a lot of the action takes place, is at the level of the entire industry. And you've got growth, a growth of the whole industry, which makes room for making money with weird new ideas. You've got increase in capacity in order people actually know how to make cars. You've got networks forming of gas stations. You've got institutions forming like traffic laws. And then driving a lot of this stuff is changes at the level of the society. And he really identifies conditions of opportunity. And that certainly fits with the psychological model with cortisol. We find out in periods where there's this sense of opportunity rather than risk, people take a lot more risk. At the technology, one of the things that he finds that's really important is to see how technologies grow within particular isolated niches, not across the whole society, but within a small segment of society. I hit upon a newspaper story a couple weeks ago. It was describing what was the best-selling luxury car in the first quarter of 2014. In every car where this particular model is available except for Germany, which suggests that it probably isn't a German car and probably is a new car that's not available in all countries. And the answer is it's the Tesla S-Class car. The best-selling luxury car in every country where it's sold, except for Germany, is the Tesla S, which is an electric car. And it got me thinking, you know, what's the initial niche market for electric cars? A lot of people had assumed it was the economy class car market because people who bought economy cars, they must care about the environment and they would want to get an electric car. If you actually think about it, it sort of makes sense that it's the luxury car market. If you think about how important is price? Well, price is really important in the economy car market, and it's not terribly important in the luxury car market. In fact, the profit margins on luxury cars are huge, and you could sneak into the luxury car market, as Tesla has done, not charging any more money on your car, but also not making quite as much of a margin. You could sneak into there. What about the range of a car? Well, it's incredibly important in the economy car market. People who have economy cars often have one car, and they need that car to do everything, including go on the family vacation somewhere. People who own luxury cars, like their Mercedes S-Classes, are driving business colleagues around town, and when they go on vacation with their families, they have a Range Rover to do that. So the range isn't so important in the luxury car market, which is the biggest single problem with electric cars. They don't go that far before you need to recharge them. What about comfort and performance? Well, it turns out that's not terribly important for the economy car market, but that's where the luxury car market's all about. And electric cars just rock when it comes to comfort and performance. They're faster than any other car at slow speeds. And they're by far the quietest, which the luxury cars, one of the big selling features is how quiet they are inside, and nothing is quieter than an electric. Who here has driven an electric car? You know, when you're going slowly, they're completely silent. You can talk with your stockbroker very easily without being disturbed. What about the environmental impact? Well, we'd always sort of assumed that the economy car market was the place because these are the people who care about the environment. Well, it turns out that rich people care about the environment too. They just have more money to screw it up. Anyway, so we should be thinking carefully about where the niches are. I'm getting to the very end. We did a study a couple of years ago where we basically took this transition model and we looked at whether or not what was happening in Europe was consistent with what ought to be happening if we had a transition model. So we sort of took this three-level approach: political leadership at the top, technology, performance, capacity, and cost at the bottom, both of them driving changes at the level of the industry, in this case the power industry. And we broke that up into these different institutions and networks and stuff. We looked at market structure, investment climate, and planning and permitting rules. Arguably, investment climate is a top-level thing, but we put it in the middle. And we looked at all the things that happened in 2010, which might influence the power market. We had 15 different events we looked at, which included change in regulatory systems at the European level, the writing of the renewable energy action plans in EU countries, the Arab Spring that happened in 2010, a whole lot of things. And we analyzed and we sort of rated them on what could we tell about these 5 factors in each of those 14 events, and then we aggregated across. And what we found was, actually, we saw a hell of a lot of political leadership, and that was green. We ranked it green, which was just as good as we need if we're going to be on course towards reducing our emissions by 2050 by 80%. Actually, this built on a previous report we'd done the year before, where we actually tried to map out what would need to happen over the next 40 years in order to get to a 100% renewable. And the political leadership was perfectly consistent with what we said needed to happen. The technology, performance, capacity, and cost, the changes that we saw, were also completely consistent with what we needed to see happen. The market structure and investment climate were a little bit yellow lights. They were in between. They were pretty good. There were some positive developments. They weren't quite as fast as we needed to see. One of the big things with market structure is, for example, the integration of the European power market, which you probably need if you're going to balance out intermittency in renewables. We're starting to see that, but it's happening slower than our previous report had suggested it needed to. The investment climate, in terms of the number of investors being brought into this market to allow the kind of growth we would need in renewables, was pretty good, but it wasn't quite as big. There was one big red light, and that was the planning and permitting rules. And this showed up as really we're making no progress and maybe even going backwards. It turns out if you're going to have a very high level of renewables in society, you probably need more power lines to move electricity around, to things like smart grids and stuff like that. And you need to build a lot more power lines. You need to get the land to build it on. And in Europe, even more than in the United States, that's very complicated, especially when you're crossing national borders. And building power lines in Europe can take 10 years. It can never even happen because of the complexity of the rules and the differences in those rules across different European countries. And this could well derail us from a revolution in the energy system, the amount of time it takes to get the permission to build transmission and, in some cases, generation infrastructure. This is, of course, something which is entirely different than we're usually thinking about with climate change. With climate change, we're thinking about, most of the time, things like the carbon price, or have countries signed up to the treaty. We're not thinking about what's the system by which we reimburse a farmer for a power line crossing her land. We're not thinking about that for climate change. We need to be thinking about that. It's a very different kind of thing to be thinking about. But that's ultimately, that's often the kind of thing which is a barrier to the sort of innovation taking place and market diffusion that we need to come up with. Okay, the end. Let me summarize. I think the 2 points, they're in gray here because I didn't actually talk about them, I sort of assumed them. First, we need an energy system transition to eliminate emissions, fine. Effects on the economy as a whole are of relatively minor concern. Certainly effects on particular actors within society are of major concern. I think the first point that I tried to argue is we won't get a meaningful global climate treaty until we show that an energy transition actually works in those countries that actually try it. And that's our task in places like Germany and places like Switzerland. It's stuff in Switzerland, we're debating it every day, and it's in the newspaper every day. How do we structure an energy transition in Switzerland that actually works? Carbon price instruments are great for low-hanging fruit, and they've been demonstrated to do a great job at that, but not for promoting the innovation needed for a successful full transition towards something like 100% emissions reduction. They just don't hit the innovation where the innovation takes place with the actors who are actually responsible for that innovation taking place. There have been a lot of studies, and it's shown they've had very, very little impact on that, whereas other instruments have been shown to work exceptionally well. So why would you want to throw out this? If you're not so much concerned about the global efficiency of this, maybe you want to take the instruments you know that work, even if they're slightly less efficient than the instruments that don't seem to work, which are more efficient. The third bullet point is technology-specific support policies, especially those that reduce investor uncertainty, promote risk-taking and innovation the fastest. And there's no doubt about that. The Feedin tariff in Germany has worked beyond all expectations. It's not perfect, and it's creating problems now, and moving forward, we need to figure out how to fix it. But rather than throw it out and go towards these other instruments like trading, more market-based ones where they don't seem to promote innovation, we need to stick with the things that promote innovation and fix the problems that are with them. Fourth bullet point, we need policies specifically aimed at industry-wide factors, market structure, permitting processes, networks, things like that. It's nitty-gritty stuff, and it's very specific to different technologies and different kinds of markets. The power market, things like networks for electric cars, if electric cars are going to be the answer, which probably in the next 40 years they are. Maybe 80 years from now other things will be, but we're not talking about 80 years, we're talking about 40 years. And then the final thing is I don't really know what creates a culture of opportunity, which seems to be important to drive risk-taking behavior and seems to be important according to all the research on technology transitions. I have some ideas, and one of my ideas actually is probably going to piss a lot of people off, and that is we all assume we need more energy efficiency and we need to contract the amount of energy we're using if we're going to achieve our climate change goals. It may be that that's actually not creating a culture of opportunity at all. It's creating a culture of pessimism and risk aversion, and that it's only within conditions of market growth that you get a strong transition to new kinds of technologies. I don't know. Another thing that might create, one of the big changes we've seen in the last few years is a liberalization of a lot of these industries. I think we need to look at whether that liberalization, whether that creates new opportunities or whether it more creates new risks. Lots of things to think about and do research on. I'm going to end where I started, which is with this slide. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. I think maybe we can avoid destroying the planet, and that would be kind of a nice thing. The irony is that probably the way we avoid destroying the planet is by creating value for shareholders, and we need to search for those ways. Thank you very much.